In this lesson, we're going to talk about Ohm's Law. Ohm's Law is one of my favorite things, and I'm just going to go over it with you. We're going to take our time, go over each different procedure and all the different aspects of it. We're also going to cover the law of power, too, or the power law. All right. Ohm's Law is just a formula, just like a formula for anything. So if you want to figure out the volume of a room, you just do the length times the width. Well, what we're going to do is we're going to use Ohm's Law to find the different parts of a circuit. So using Ohm's Law, we can basically figure out all the different values of all the different parts of a circuit. So let's look at the first one right here. So right here we have the basis of Ohm's Law. We're going to use a V instead of the E in this lesson. So normally it would be E over I times R, but we're going to use the V because it seems to work a little bit better. So V, of course, stands for volts. I stands for amps. And R stands for resistance. Wow, that's an awful omega. All right, so using this, we can find any value in a circuit that we want. All right, so in this situation, we have voltage, we have a load, which would be resistance, which would be ohms. We have battery, which would give us volts. And then right here, if we cut that circuit apart, we'd have our amps. So with Ohm's Law, we can discover the different parts. So let's just go back to that first screen again. So if I want to find voltage, I basically put my finger over the V, and that gives me I times R. Now, if I want to find I, which is, of course, amps, I put my finger over the I, and that basically tells me that it's V divided by R. Or if I want to find resistance, which is R, I put my finger over that, and it tells me V divided by I. So what I recommend is that you draw this triangle every time you want to do Ohm's Law. I still do it myself, and I've been doing this for a while. So if you want to find volts, you put your finger over the volts, and it's basically I times R. They're next to each other. If I want to find amps, I put my finger over the I, and that gives me V divided by R. And if I want to find my resistance, I put my finger over the R, and that gives me V divided by I. So let's put it into play. Let's check this out. All right, so I have a battery here. I have the same circuit I had on the other page. So basically what I'm going to do, I'm going to assign my battery a value. Well, actually I'm not, because I'm looking for volts. So what I'm going to do is I'm going to get my amps here, and I'm going to, or my lamp, and I'm going to say that that has a value of 5 ohms. And then I'm going to basically put my amps here, and I'm going to say my amps equal 2 amps, or my R equals, and my I equals. So I'm going to draw my triangle right here. So I got my volts, my amps, and my resistance. So I'm looking for volts. So I basically want to put my finger over here, and I have I times R. So do I have an I? Yes, I do. My I equals 2. Do I have an R? Yes, I do. My R is 5. So I'm going to use some easy numbers here so we can do them in our head. So 2 times 5 equals 10, and that is what? 10 volts. So my answer is 10 volts. All right, let's check out this next one. Next one is amps, okay? So I'm going to draw my triangle. Like I said, I recommend you draw your triangle all the time. Oops, that's awful. All right. So, volts, amps, resistance. And again, I'm going to use the same circuit I used last time, and we're going to find amps. So over here, I have 10 volts, and I have 5 ohms. So let me just put my finger over the I, because that's what I'm looking for. And that gives me V divided by R. So let's do that. 10 divided by 5, or 10 divided by 5. So how many 5s are in 10? 10 divided by 5 equals 2. We have 2 amps. Same answer we got last time, 2 amps. 2 amps is our answer for this. All right. So now we're going to use the same equation we've been using. Draw my pyramid. E, I, R. What am I looking for now? I'm looking for ohms. So I'm going to put my finger over the R. That gives me E divided by I. I'm going to go back here and look. I had 10 volts. I had 2 amps. So E is what? 10 divided by I. So let me write that out over here. E divided by I. And I could just put equals there. So E divided by I equals 10 divided by 2. And 10 divided by 2 equals 5. And since I was looking for ohms, I can put 5 omegas, or 5 ohms. All right? So you can see now that having 2 of any of these values right here, I can always find the third one. So let me scroll down a little bit. All right. Power law. It is exactly like Ohm's law. Ohm's law was what? Or V, sorry. I times R. This one's the same idea. But the nice part about that one is it spells pi. But it really doesn't here because we're using V. But if we used an E, it would spell pi. P equals I times R. And that is absolutely wrong. So I'm going to go up here and I'm going to click that. P-I-E. Pi. E stands for electromotive force. Electromotive force stands for volts. So P-I-E, or P-I-VIV in this case. So sometimes the V helps us, sometimes it doesn't. But in this case, P-I-E, pi. So P-I-E. All right, so remember that. Power is pi. Power is pi. All right, so using this, we can do the same thing. If we put our finger over the P, that gives us I times E, or I times V. If we want to find the amps, I put my finger over the I. That gives me P divided by E, or P divided by V. And if I want to find, if I have the volts, I put my finger over the volts, and that's P divided by I. So let's put that into play. So I'm looking for watts here, okay? So we know that our battery has 10 volts, okay? And we know that we have 2 amps here. And I also know that I have 5 ohms here. So let's draw my power triangle. Put my P at the top, I, and then E, or V in this case. All right, pi, P-I-E. E also stands, V and E are interchangeable. So can I use ohms? No, that's not even one of the choices. So we're just going to forget all about that. So what am I going to do? I'm going to get P equals I times V. I times V. All right, I got that. So do I have an I? Yes, I do. I have amps. So that's 2. Do I have V? Do I have volts? Yes, I do. All right, so the watts of this circuit, or the power that's used up in this circuit, is what? 2 times 10. That would be 20, and that would be 20 watts. All right, do we see how easy that is? So again, we're using our triangle, PIE or PIV in this case, but E and V are interchangeable. Remember that. Electromotive force is another name for volts, which is what we use. All right. So here we go. We can find out volts, or we can find our watts by getting the amps times our volts. 2 times 10 equals 20. So our answer to this is it's a 20-watt circuit. All right, so here we go. We're looking for amps, okay? So I know that this is a 20-watt circuit because we just figured it out. And I know that my battery has 10 volts, but I don't know what my amps are. So how am I going to find that out? I'm going to draw my circle, or my triangle. You can also make a circle too. And I'm going to put P, I, E, or in this case, we're using V, right? Piece of pi. Remember that, piece of pi. So I'm looking for amps, right? So I got P and V. P is divided by I. So P divided by I equals, what's my P? It's 20. What's my, oops, not divided by I, I'm sorry. I'm looking for I. It's divided by E, or V. All right. So what is that? That is 10. 20 divided by 10 is 2. 2 what? 2 amps, or amperes. All right. Easy peasy, right? All right, one more. All right, I'm looking for volts now, okay? So I know that I have 2 amps in this circuit, and I have 20-watt light bulb here, and I'm looking for my battery, my volts. So I'm going to draw my triangle. Don't forget to draw your triangle. P, I, E, or V. All right, piece of pi. Remember that, piece of pi. So I got my piece of pi here. I'm looking for what? I have my amps and I have my watts. I'm looking for my volts. So I put my finger over here. That gives me P divided by I. P divided by I equals, P is 20, I is 2. 20 divided by 2 is 10, and my answer is 10 volts. Wow, that was awful. $10. All right, easy peasy, right? You guys got this, right? So I know there's a couple questions that are on the final that ask you if something goes up, what happens to everything else. So I want you guys to look at this. I got my resistance right here. The more power that he squeezes on that rope, the slower this amp guy can get through. That makes sense? So if I have a lot of amps, it's going to put a lot of pressure on this rope, and it's going to squeeze it and make this hole smaller so that the amps are going to have enough time going through. So it doesn't matter how hard the volt guy pushes on this amp guy, if the resistance is squeezing the tube, he's going to have a tough time. So the more resistance, the slower the amps. Makes sense, right? If I want to get the amps faster, I'm going to have to put a bigger foot to give them a kick, right? So if this is my 10 volts and this is my 5 ohms, and this guy down here is my 2 amps, if I wanted to get the amps to move faster, but the resistance to stay the same, I'd have to add more volts to give him more of a push. So let's put that in effect and see how that works out. All right, so let's go back here. I'm going to do just what we just did. So I got 10 volts, and I got my 5 ohms, and I got my 2 amps. All right, so if I make the amps go up, but the resistance stays the same, so I'm going to change my amps now to 4 amps. But my resistance stays the same. We know that if two things always affect the third one, right? So let's think about this. If I make my amps go up to 4 because I need 4 amps to go through my circuit, but I'm not changing my resistance, that means that my volts would have to go up. So if we use our Ohm's law triangle real quick, we want to see what our volts is. So we're looking for that. That's a question mark. But we have our amps and we have our resistance. We can figure it out. So I times R equals V, right? So I have my R, it's 5. My amps are now 4. So 5 times 4 is what? 20 volts. So if my amps go up and my resistance stays the same, that means my volts have had to change. So my volts now are 20. So let's do that again. So I have my 10 volts. I have my 5 ohms. And let's see. Let's do this. Let's say my resistance doubles. So my resistance is now 10. My voltage stays the same. I'm going to draw my little triangle real quick. So I got V, I, R. So my volts are going to stay the same and my amps go up. So my resistance goes up. So I'm looking for amps. So I got V divided by R. Volts is 10. Resistance is 10. So my answer is now 1. 1 amp. So what happened? My resistance went up and my amps went down. So you can see how everything affects everything else. Let's do another one. So I have my 10 volts and I have 2 amps, but you know what? I'm going to jam that. I'm going to jam that up to 4 amps. All right? So now I want to know what my new resistance is. So let me draw my triangle again. So my amps went up, but my volts stayed the same. So I'm going to draw my triangle. I'm going to put V divided by I and R. I don't know my R, so I'm going to put my finger over that. That gives me V divided by I. Do I know what V is? Yes, I do. It's 10. Do I know what I is? Yes, I do. It's 4. So how many times does 4 go into 10? It goes in 2.5. So my answer now is 2.5 ohms. So what happened? My amps went up, but my voltage stays the same. So that meant what? My resistance went down. So you can see, when something goes up, something has to go down. So when amps goes up, voltage stays the same, resistance goes down. If resistance stayed the same, in this case, or we can use the case up the top here, if resistance stayed the same and amps went up, that means volts would have to have gone up too. So depending on the situation, it's how it works. Usually amps and volts run together. So if amps goes up and resistance stays the same, volts have to go up. If volts goes up and resistance stays the same, amps goes up. So if resistance stays the same, the volts and the amps are hooked together. Let's do one more. So let's say, what didn't we do already? Let's work on volts. All right, so I don't know what my volts are. They're usually 10. But in this situation, my amp stayed the same. And my resistance quadrupled. So my resistance is now 20 ohms. So I'm putting a more restriction on here. There's more resistance for it to go through. So just like I said over here, if amps go up and resistance goes down, but if amps goes up or stays the same in this situation, I can kind of guess. If resistance goes up, which means that it's going to take more force to go through, but the amps stay the same, I can guess that my volts are going to have to go up. And I can guess that my volts should be 40 now. But we'll see. All right. So I'm looking for volts. Put my finger over that. I got I times R, 2 times 20. 2 times 20, and that equals 40 all day long. $40 volts. And there you go. My volts went up. So when in doubt, if somebody asks you if volts go up in a circuit and resistance stays, make your triangle, throw a couple numbers in, and figure it out. It's easy peasy. All right. Now let's put all of our newfound knowledge in effect. All right. So I'm looking at my circuit here, and what am I looking for? Calculate the amount of current that will go through a resistor in a circuit. All right, so I'm looking for the current. Do I even care about the resistor? No, I'm really just looking for the current. So what do I have here? First thing I'm going to do is draw my triangle. All right, volts divided by resistance and times amps. What do I have here? I have resistance and I have volts, and I'm looking for my current, which is this one here. I put my finger over here. I don't even need to know about anything else. I'm going to get volts, and I'm going to divide it by my resistance. My volts are what? I have 12 volts. My resistance is 470. I'm going to use my calculator here. I'm going to get 12, and I'm going to divide it by 470. Hit the old equals, and it comes out to be one crazy, crazy, crazy number. I'm just going to grab a couple digits of it. 0255. 0255. 0255. So that's my circuit right there. If I want to know what my amps are, if I could cut this wire and put an amp meter in here, that would be it. Or I could say milliamps. And remember, milliamps is when we just move the decimal point over 3 places. 1, 2, 3. So if I wanted to make this into milliamps, it would be 25.5 little m big A. And, oops, any one of those, wow, that was awful. Any one of those would be right. All right. So let's look at this one. I have an alarm clock that draws 0.7 amps of current when connected to 120 volts. So let's see what we got. We have amps and we have volts. And then it says, calculate the resistance. Draw my triangle because that's what I always do. E-I-R. And then what I'm going to do here is I'm looking for what? Resistance, right? Put my finger over the R. That gives me E divided by I. E divided by I. Do I have E? Yes, I do. It's 120. Do I have I? Yes, I do. It's 0.7. So I get 120 divided by point. Don't forget the point. You guys do this a lot. 0.7 equals some crazy number for resistance. And I'm just going to keep it a whole number. So 171.4. 4 is lower than 5, so I'm not going to round it up. So it's going to be 171 ohms. That's my answer, 171. Let's check out the next one. All right. A light bulb has a resistance of 8 ohms. The maximum current, so I'm talking amps here, is 10 amps. How much voltage can be applied before the bulb breaks? Well, I don't know exactly how much it can be applied, but if it's running at the perfect volt, if it's running perfectly with 10 amps going through it at 8 ohms, that'll give me that'll give me a voltage. Okay, so let's just say that at 10 amps is the perfect voltage for this light bulb. So I have I and R. I keep writing E there because it's out of habit, but E or V, whatever you want to do there. That looks super confusing. Hold on. E/V. All right. So I got ohms and I got resistance. And I'm looking for my volts. And again, I'm just going to put my finger over that. It gives me I times R. 8 times 10. How did I get to 8 times 10? I had resistance times I. Resistance is what? 8 amps is I. There it is right there. I don't even need a calculator. 8 times 10 is 80. 80 what? 80 volts. 80 volts can go through this lamp, this light bulb, this lamp. Hopefully that's the specs or the parameters that was put up. All right, here's a couple of them. It's kind of the same circuit. It's asking me what is the current. They're all asking what the current, and the voltage is the same. The only thing it changes is my resistance. So here it's 20, here it's 10, here it's 5. So let's do this. I'm going to do the first one, and then I want you guys to do the second one. I'm going to pause a little bit, or you can pause the video a little bit and do the second one, and then pause the video and then do the third one. All right, so I'm going to draw my triangle over here so I can use it for all of them. And I'm not going to scribble on it. All right, so I'm looking for what? I'm looking for the current, and I have volts, and I have resistance. Volts, resistance, volts, resistance. So easy peasy, right? So I'm going to use my formula here. I have volts and resistance. So basically, if I use my formula the right way, V is divided by R. And I can just go V divided by R, V divided by R, because they're all exactly the same. So what's my volts in this one right here? It's 160. I'll make the 6. 160 divided by 20 equals 160 divided by 20 equals 80, right? An easy way, if you got things with zeros, just take one of the zeros off, but you have to put it back on. So if I take this 0 off and this 0 off, so 16 divided by 2, 2 times what equals 16? 8 and 8 is 16. And then I put the 8, and then I put that 0 I just crossed off back on over here. Okay, so in this one I have my voltage of 160, and I have a resistance of 10. So just to keep things a little sane, let's do this. So 160 divided by 10 equals 16. The answer for this one is 16 amps, just like this was 80 amps, because I'm looking for current. All right, so I want you guys to do this one on your own. Okay, so I'm going to help you out a little bit. What is the current in a 160 volt circuit if the resistance? So again, we got it all figured out over here. I have my what? What do I want to put here? 160, right? Exactly. Divided by my resistance, which is what? 50. And I'm going to have to figure that out. Oops, I'm sorry, not 50. Just 5. So 160 divided by 5. So I'm going to pull my calculator up. 160 divided by 5 equals 32. So the answer is 32 amps. All right, sort of the same circuit. We're going to do the same exact thing. I know this might be getting a little boring, but please bear with me and follow along. All right, so I got my circuit here. What do I have? I'm looking for voltage, and I have amps and resistance, amps and resistance, amps and resistance. My amps are being multiplied by my resistance. They're next to each other, right? So I'm going to put my finger over the V. I times R. I times R. I times R. I times R. My I is what? 6. My R is what? 5. 6 times 5 equals 30. 30 what? 30 volts. All right, let's do the same thing down here. 6 times 10 equals 6 times 10 equals 60. 60 volts. Because I used my amps and my ohms. Down here, what do I got? I got 6 amps times 20 ohms. 6 times 20 equals 6 times 12. 6 times 2 is 12, and add the 0 onto it. That's 120. 120 what? Volts. All right, we just got a couple more to do. Let's sort of knock them out. Hope I'm not losing you guys. All right. So how much how much voltage would be necessary to generate 2 amps in a circuit that has 1.5 ohms? So that's all I'm really looking for. So I have amps and I have ohms. What's the first thing I'm going to do? I'm going to draw my triangle, of course, because that's what I do. So I'm going to draw my triangle, and in my triangle, I'm going to put volts, I, R. I'm looking for volts. I put my finger over the volts. I times R. So that's going to give me I times R. I is what? 20. R is what? 5.5. Grab my little handy dandy calculator, which I recommend you guys do. 20 times 5.5 equals 110. 110 what? 110 volts, because that's what we were looking for. Remember, we covered up the volts? All right. Now we're going to look for something a little different. I have my amps. I have my volts. I'm looking for power. So what's the formula for power? Do we remember? Pi, right? P over I E or V, right? So I'm looking for power. I'm going to put my finger over the P. That gives me amps times volts. Do I have amps and volts? Yes, I do. Amps and volts. So I have I times V. I have 5 I's and I have 6 V's, and that equals 30. 30 what? 30 watt? Yes, 30 watts or 30 W, right? I have a portable hair dryer, and it uses 110 volts and has a current of 10 amps going through it. What is the power? So let's figure this out. First thing I'm going to do is what? The first thing I'm going to do is draw my triangle. Remember, it's the formula for power. Power is a piece of pi or, oops, right? I'm looking for power. I want to put my finger over the P. And I got what? I times V. I is what? Amps. V is what? Volts. Get my handy dandy calculator. I'm going to get, oops, I'm not going to do that, am I? 10 times 1,000. 1,100 watts. Big W. Now, you know what? I'm curious. Could I figure out what the resistance of that portable hairdryer is? How many ohms is that portable hairdryer? Of course I can. Draw my triangle. I got V at the top. I, R, right? So I'm looking for resistance. I'm going to put my finger over the R. That gives me volts divided by amps. Do I have volts and amps? Well, of course I do. I have 100. Well, let me do it over here. Volts divided by amps, or I. I have 110 volts. I'm going to divide that by the 10 amps. How many times does 10 go into 110? Well, that goes in 11 times. And that's going to give me 11 ohms. So I can use the formula for power to find lots of things, but I really need Ohm's law to find resistance. So if I have power, I can find amps and I can find volts. If I have the amps and the volts, I can find the resistance. All right, we only have 2 more to do. Let's see what we got here. All right, an electric heater draws 111 watts of power. It costs 8 cents per kilowatt. How much does it operate the heater for 3 hours a day for 36 days? Well, I don't need my power formula for that. I'm just going to find out a couple little things here. So I have 1,100 watts. First thing I have to do is convert it to kilowatts. Why do I have to convert it to kilowatts? Because we always convert it to kilowatts when we find the cost. Because the cost is per kilowatt. So how am I going to find out how many kilowatts are in a watt? I'm going to move the decimal point over 3 places to the left. 1, 2, 3. So that gives me 1.1 kilowatts. Okay? Now, when we figure out kilowatts, it's a kilowatt. See, it's saying it uses 110 watts of power. Well, that's in an hour. That's how they figure that out. So it uses 100 or 1,100 watts of power in an hour. So it's telling me that it's somebody dries their hair for 3 hours a day. Well, that's kind of insane. So we got a couple ways we can do about it. We can figure out how much it costs per 1 hour, or we can figure out how many hours over the course of 30 days it's used, and then figure out how many kilowatts. So I'm going to do it both ways for you. So first way I'm going to do is it's used for 3 hours a day. So I'm going to multiply 1.1 times 3. So if it uses 1.1 kilowatts for 3 hours, that's going to be 3 times 1.1. So I'm going to put that here. 3 times 1.1. And that's going to equal 3.3. And that's 3.3 kilowatts. So now I know that's 3.3 kilowatts per day. All right, but they're using it for 30 days. So to figure that out, I'm going to multiply it by 30. So I got 3.3 times 30. So let's grab our handy dandy calculator, and we're going to go 3.3 times 30, and that equals 99. So that's 99 kilowatts. But I'm not done yet. If 8 kilowatts, if each kilowatt costs 8 cents, I'm going to have to go 99 kilowatts times. Remember, when we do change, we have to do the decimal version of change. So 8 cents is really 0.08 equals. All right. So what we're going to do is we're going to go 99 times 0.08. Because remember, don't forget, we have to do it in the decimal version. So 8 cents is 0.08. It's going to cost us $7. Oops, that jumped away pretty quick. And 92 cents. So if your girlfriend, mom, sister, aunt, grandma uses the hairdryer for 3 hours nonstop every day for 30 days, it's only going to cost $7.92. So I told you I was going to do it a couple ways. I recommend doing it this way. Figure out how many kilowatt hours over the course of the time, and then multiply it by the cost. All right, we got one more to do. This one's a little trickier, so we actually have to read it. So let's read it. The headlights for an automobile have 2 power ratings, a 45 watt for the low beam and a 65 watt for the high beam. How much current in the headlight filament of the headlight bulb for both of these settings when 12 volts is provided by the car battery? So what are we looking for here? Let's look this over. So we have watts and we have volts. And it said here, how much current? So we know current is what? Amps, right? So let's draw our little triangle here. We're going to use our formula for pi, our formula for power, which is pi, PIE, or PIV. What do we have? We're looking for amps, right? So we're going to have to do two of them. So we're going to get P divided by, and we're just going to say V. So what's our P? Our P is 45, and our P is 65. And our volts are consistent through the whole thing. So our volts are 12, and our volts are 12. So we're basically looking at how much amps go through the light bulb at the different settings for the light bulb. So basically in a car you have high beams and low beams, really bright lights or dim lights, and each one uses a different watting. So as you guys know, if you put a 100-watt light bulb in your bedroom, it's really, really bright. And if you put a 25-watt light bulb in your room, it's really dim. So this is going to be the low, and this is going to be the high beams. All right, so let's figure this out. Let's get our calculator out. We'll move it here out of the way. So I'm going to get, the first number I'm going to get is 45, and I'm going to divide that by 12. And that's going to give me 3.75 amps for this one. And then I'm going to put my calculator back up. And I'm going to get 65 divided by 12. And it's going to give me 5.4. And since that's a 6 there, I'm going to round that up. So it's going to be 5.42. 5.42 amps. So there's our two answers. Make sure you always put the amps or the ohms or the volts or the watts there, because I'll take points off for that. And that's it. That's sort of wrapping it all up. Now, I gave you all these questions in this assignment. So what I want you guys to do is I need you guys to go back through and work on them yourself. We went over them one time, so now it's time for you to go over them. And if you have a question, find it, you have a problem, find it in the video, this part. If it's this question, go scroll all the way to the end and, look it over and see how you did. All right? Good luck. And I know you guys got this, and I'm proud of all of you. Have a great day, and see you back in class.